Hi everyone, I'm Amy. I'm a technical evangelist at Microsoft, and earlier on this year I spoke at Devoxx UK. It was a wicked event. I really enjoyed being there. So actually, they invited me along to speak in Belgium now. So absolutely lovely country, never been before. So thank you for inviting me. And today I wanted to talk a bit about. I've got quite a wide title here: predicting the future with machine learning. Basically, I want to talk to you about how machine learning is now available to sort of all of us and how you guys can literally leave this room and start building your own machine learning models. There's less of a barrier to entry. There's less of, having to have all the infrastructure and stuff like that. So it's a really exciting time for machine learning. So this is machine learning. We're over here. This is machine learning. This is actually called the Hebbian rule. It's a linear model. It's used in neural networks. Some of you are looking a bit concerned. Am I in the right talk right now? Is this actually what I want to do? Don't worry, I'm not going to talk through this. What I am going to talk to machine learning is like this. So if you can handle that equation, we're all good. So basically, what do I think machine learning is? Well, I think it's where computing systems become smarter with experience. So experience, let's break that down a little bit. So past data plus human input. We have so much data now. We have data, we have weblogs, we have social data, we have data from customers, we have data from devices, we have data from so many different places. Are we actually using that data properly? Are we using it to its full advantage? And is it completely efficient the way we're maybe doing it? So again, we have loads and loads of data from the past that we can actually start to use for the future. And then the human sorry, I didn't realise I've not turned off my Twitter things. The human input. What do I mean by human input? That's kind of the machine learning part, I think. Two forms. We can have supervised machine learning. Some of you guys in the room might have heard of that. So supervised machine learning is where we're involved. So I might say, okay, I have some past data, and I have the right answer. I know what happened when that line of data happened. So, for example, flight delays. I've been doing some work with flight delays. I've pulled together flight data and weather data, and I've been able to say okay, can I predict whether a flight in the future is going to be delayed? And it might depend on how visible it is outside. It might depend on the wind speed. It might also depend on the carrier, which is an unusual one. So, who you're flying with, maybe that makes a difference. So having that answer, that true answer of what happened in the past, you can pass that data into a machine and actually get it to see what might happen in the future. The second form of human input is called unsupervised learning, so the opposite, and we're not involved in some senses. And the machine learning algorithm kind of takes pieces of data, it looks at them and it goes, okay, I understand that piece, okay, and it takes another piece of data and it takes another piece of data. And actually, that's when it starts to tweak itself. So each algorithm probably has many different variables, many things it can change, and actually it starts to tweak itself. So that's really good. But I think sometimes the best way to talk about machine learning is actually through examples, because this stuff is there now. Machine learning's kind of come across as a big talking point at the moment, and everyone's like, what do we do with machine learning? And then there's the whole kind of dark side of machine learning as well that people are discussing. But actually, this kind of stuff is already built into systems. So I've got a kind of explosive icon here. Predictive maintenance is an exciting one. We've had lots of customers that I've spoke to that have wanted to start to be proactive around maintenance rather than reactive. So we worked with a lift company. They've sort of put devices and sensors on all of their lifts all over the world. They've got absolutely millions of them. And what they've been able to do is actually get lots of data from those lifts, and they've started to actually be able to predict when things are going to break down, so that they can have the right person at the right time with the right part in the right place. I mean, that works for everyone. That works for the business. They're not losing money. They're not putting people in the wrong place. I mean, how annoying is it when you have something broken at home, and then someone, you get a handyman around and they go, oh yeah, that's broken. Yeah, I know. That's why I called you here. But actually, and then they go, it's going to be a week until I can get that next part. No more. What if we can start to predict what's going to go wrong so the person can just come and fix it straight away? So predictive maintenance, an exciting one. Another one where everyone in this room has, I thought I was going to be affected by this actually in the last few days, credit card fraud. So when you go abroad and maybe you're not using your card as you normally do, so I'm normally in around London, so in the UK, so I tend to spend in there. I'm drinking coffee a lot, do a lot of shopping, get a lot of trains. So that's my usual pattern. So they're taking my pieces of data and they're starting to build a model around how I spend my money. And actually then, when they see something that's not quite right, it's kind of like a little red flag in the air, and they go, something is a bit unusual here. This might be someone else using her card. We should flag it. So that's kind of credit card fraud. That's how it works with machine learning behind it. And again, this is used by pretty much everyone's banks. And it's been quite a while since this has been put in place. So again, not new stuff necessarily. A wavy hand. I found it really hard to find a symbol for this one, so bear with me. But the wavy hand, there was a really interesting project that Microsoft Research did recently around using a Microsoft Kinect sensor, which is based around machine learning anyway, to understand where different parts of your body are. And actually, they were able to have someone come up to the camera and actually do sign language in front of it. And then the computer was able to interpret exactly what the person who was signing was saying. And this kind of computer vision, speech to text kind of thing, but with sign language. So it was really exciting because they were able to see all the different, we have really complex hands. When they showed me, I was like, wow, we do, don't we? Who knew? But so we have complex hands that they're really understanding how we're moving them, how we're twisting them, how we're pointing. And people have different hands as well. I mean, I have really, really thin fingers. I have really long nails. So actually, like, my hand might look different to one of your hands. So that was a really, really exciting part. Okay, so a little recommender basket. This one's probably my favourite one. So they get me every time with this. So you buy something online, you put it in your shopping basket, and then basically forever and a day, you're going to be recommended something that goes with that item. You buy one thing and you will be recommended, you will be emailed, they will send you discounts and everything. That's a recommendation. So basically they're saying, you've got, I don't know, I bought, I got my phone, and then actually they recommended me a phone case. So I was like, yeah, I need a phone case because it's actually cracked, which is a nightmare. But yeah, so they recommend me a phone case. If you buy a laptop, they'll recommend you a laptop bag. If I buy one dress, they recommend me exactly the same dress, but in a different colour probably, which I did buy in the end. So exciting stuff. Recommendation engines are built into your favourite search engine, into your favourite online shopping sites. But if you guys have a website, and maybe you have an e-commerce one, maybe you want to implement that kind of stuff. Well, why is it just big business that should be allowed, be allowed to use this? But I wanted to point out as well, machine learning, it's not a right answer. It's not something that is a true north. It's a probability. It's something that we're saying, oh, I'm trying to point you in the right direction in some senses. So sometimes it can go a little bit wrong. Has anyone got like a home automation system? You can turn your heating up and down with it from your smartphone. Pop some hands up if we've got some. Yeah, oh, okay, yeah, you guys are really good. Sometimes there's like no one, I'm like, oh. But so a home automation system. And those people with their hands up, can you tell me how many of you bought a 76 centimetre inflatable dinosaur with it? Bit of an odd one. So this is actually a guy in my team, and he was like, I want to get one of these Hive home automation systems. I think it'd be really cool. And then he sent me this email saying, I'm not sure they've got this quite right. Where have they got this dinosaur from? But basically someone out there has bought this combination, and maybe there's a bit of a data skew. Maybe they didn't have that much data at the time. Machine learning can start with a very, very small amount of data, and it can give you some unusual answers. But then over time, as you add data to it, you can actually start to really get to the really pinpointed decisions. And maybe in the future, maybe actually if I went back now, I bet this wouldn't happen. So that's the thing. It's a time thing. But yeah, that's Yeah, I thought it was really funny. But yeah, so I kind of said, this stuff's already there. We've got loads of examples of it. But why is it now that we're getting sort of excited in industry about it? Why is this room so full? It's basically the question I'm asking. I'm really glad you're here, though. But the exciting thing is this is no longer in research. This is no longer just for big business. And personally, I think it's down to 3 things that are kind of up here. So first one, the cloud. Cloud computing has allowed us to borrow compute and borrow storage and borrow certain use services that maybe some other vendors have built and actually start to build some really cool stuff without having the initial investment on infrastructure and, okay, how am I going to sort out all my different pieces of data? How am I going to partition my data? How am I going to shard it? And it all gets really confusing. And actually, all you want to do is develop cool applications. You want to be creative, and actually sometimes that initial barrier of all the setup kind of puts you down a little bit, and maybe it squashes creativity. And I think that's something now that can be really burst out of its bubble. The second one is I've kind of got like a little RSS feed. This is the data again. This is the kind of the data I talked about earlier. We have loads of data. We have data everywhere, and it's kind of. It's interesting how much social data is coming up right now, but also things that I'm maybe wearing, things that are in my phone, things that are on my laptop, things that I carry around with me every day are now producing data. And we, with all of this data, we can start to learn patterns. There was a time when we didn't have enough data to do machine learning. There was a time when we didn't have enough compute to do machine learning. And there was a time, and actually these things are now at people use the word inflection point. Yeah, so things are coming together at the right time, and that's making it more available for everyone. And then finally, the last one, kind of agile, being creative, and being able to develop quickly. Not having to say, okay, this is now going to be a 3-month project to make one initial proof of concept and that kind of thing. How about we do it in a day? How about we have a 2-day hackathon with the team and we start to build something that's maybe small now, but actually could become a lot more than that. That's the kind of thing I'd like to think machine learning is becoming. How can we build quick models? How can we build sort of test cases and say, can we find something useful from our data? So I think machine learning is here now. So what do we offer? I think as part of Microsoft, we offer something that's quite exciting. We offer something called Azure Machine Learning. It sits completely in a modern web browser. There's no heavy downloads onto your system. There's nothing like that. It all sits in the cloud, and you can pull data in from various different places. Once you have your data there, you can actually, like I said, work in an IDE that just sits in your web browser. Any modern web browser that supports HTML5 and stuff can actually start to run this stuff, and you build it in there. Also, you're borrowing, again, like I said, that compute and that storage. So, you're paying pence. You're paying like nothing for it. It's a really exciting service, and so being able to use, there's like a click and drag. I'm going to show you a really cool demo, but there's a click and drag option. It's less about the code and more about, okay, how is our data moving through this model? How can we build something pretty quickly with, an interest in machine learning? Someone said to me, could this stuff be quite dangerous in the wrong hands? And I was like, dangerous is a bit of a strong word, but I think an interest in machine learning, an interest to look up all those different meanings and these different phrases that come up is enough. That's enough to kind of get you to build a model and maybe get a few consultation hours with a data scientist and actually start to build some really interesting stuff around your data. One of the most exciting parts, and when I talk to people, this is absolutely the key part for this, is actually when you build a model, you create a web service. So we build a model and we do something called publishing it, and actually it just creates a web service for you. You don't build it, you don't have to write it, you don't have to write the documentation for it, it does it all itself. But I think actually the exciting part of that is if it's a web service, you're simply calling a HTTP request. And you can do that in most languages. So this makes it totally open. There's less barriers to say, oh, well, you don't program in this language and I don't use this IDE and rah, rah, rah. Like, it's not about that. It's kind of like, okay, I've built this really cool model and now it's in a web service. So I can just send a piece of data via HTTP requests and pull a piece of data back and get some intelligence. So, you know, that's kind of exciting. And again, on the sort of client side, what can we say there? Well, if it's in a web browser, if it's in an application, if it's a web service, we can call it from any device, we can call it from any operating system. And actually, that's a really exciting part of it. So I wanted to talk a little bit about, actually, I didn't even ask, oh, how rude. Have we got any sort of people who are really into machine learning, working with it? Pop your hands up, maybe. Data scientists. Cool, a couple of you, yeah. Welcome, nice to meet you. But yeah, it's quite interesting. I wanted to talk a little bit through the machine learning process model because I put in the abstract, you didn't need to know anything about machine learning before this talk. So I personally think you start with an idea. Lots of people maybe try and start with a data set. Not the best idea. If you start with an idea, you start with a question that you think is going to be useful for your application, or a question that will be useful for your customers, or a question that will be useful for your business, and then actually go from there. So, can I predict flight delays? Will a flight be delayed or not? I'm asking a specific question. So then I get my data together. So I go, what will be useful for that? I'm going to need the flight data. I think the weather affects loads of things, actually. Loads of customers I speak to are like, oh, I think we should pull in the weather data. And actually, that's when you go, okay, let's pull this data in. We've got an idea. I'm going to pull some data in. And now I think there's almost a need for the business knowledge as well. There's many times that you can create a model, and then at the end you kind of go, is this really that useful? If it is, that's great. But sometimes it's like, oh yeah, it tells us something, but how can we act on that? So actually having the business knowledge to say this question here that you've proposed is far more important than this question over here. So if we can get that to work, that will make loads of difference. So that business knowledge is key. And the data understanding, as you sort of get to know the data sets and the problem and the question, you'll understand your data more probably as well. You'll end up sort of going, oh, I didn't even realize that was in that data set, or oh, I didn't realize these things correlated so closely. I didn't think they affected each other so much. And we tend to have a human bias sometimes on actually what affects what, which is exciting. Then I'm gonna say it. Data preparation. It's not the most exciting part. It's not the nice shiny new stuff, but actually it's totally key. Data preparation. Some people say, oh, it's like 70 or 80% of your project is spent like preparing your data into the right format, and it's probably true. But actually, getting it into the right format with sort of rows of data, you're then able to say, okay, it's all clean, there's no missing values. My machine learning algorithm will be able to learn so many different patterns from really rich data. Sometimes that's big data. Big data, what's big data? Sometimes that's lots and lots of data. But sometimes that's not as much data as people think it is, and it's actually having that sort of pure, really, really good sources of data that tell you a lot about your problem, that matter more. Finally, onto the exciting parts and the modelling bit. So that's the bit where you pull in an algorithm, you put your personal data in, and actually you can start to learn stuff from it. So with a machine learning algorithm, which is it's kind of like it's not a rule. It's kind of it was a mathematical equation. That's what it is. There's a mathematical equation kind of thing going on over here, and actually you pull your data into it, and you say, go and learn the patterns. Go and learn all those different patterns that are in that data and see if you can learn the question I'd like you to answer. And then finally, we often sort of keep some data back. we want to know whether it's any good. It's kind of like A/B testing. We want to know whether our model is any good. So if we keep a little bit of data back, what we can do is start to evaluate how good, how accurate, how precise that model is. And that's always quite an exciting part. Sometimes your first one comes back and you're like, oh my God, it's literally sort of flipping a coin in some senses. So we need to improve it. How do we improve it? And that kind of comes around to this curve. So we need to repeat this cycle. It's all about experimentation, and that kind of takes me back to that agile point. You know, if we're really agile, if we can build these things quickly, we can experiment quickly, and we can go, okay, that didn't quite work, but what if we did this? Okay, let's quickly do that. Okay, that was a bit better. What if we do this now? What if we swap different bits out and we can start to, you know, improve our model? You know, that's this kind of agile idea. And finally, to publish, I mentioned the web service slightly. That's that part, really. Previously, you might have had it's kind of like this DevOps scenario almost, but with data scientists and developers. And you have a data scientist, he's got a huge like burning machine going on over here, and he's built something amazing. I always think of it like an orb of intelligence. I'm like, okay, this thing's really cool. It can like answer a really cool question and start to predict for us. And they actually pass it. They go, okay, done my bit. They pass it over the fence to the sort of application developers who already maybe have systems in your business or already have a website running or an application across 3 different platforms. And they go, oh my God, what do I do with this? Like it's so complex. It's maybe in R and Python, and actually you've got a website or a Java application, and you're going, oh, how do I go about doing this now? And with that kind of web service, you can go, piece of cake, no problem. If you have a web service, you call a HTTP request, you pop it into the applications you already have, and I think that's one of the key things. So I wanted to do a very, very quick demo just to show you the Azure Machine Learning Studio, how you guys can quickly get hands-on and actually start to build different models. I'm going to introduce a scenario for you. Oh, sorry, yeah, very, very quickly. It's on GitHub. Please do go and find it. There's lots and lots of resources on there, including sort of presentations I do and documents that you can sort of get started with. So I want us to all be on the same page here, so I'm going to introduce a scenario. We have this really popular data set. It's used a lot in sort of image processing, and it's a whole load of letters and numbers. So our part of the data, we're just going to use the numbers from 0 to 9, and they're all handwritten. So I think immediately people are kind of going, okay, I see where this is going. This is going towards sort of like when you send a piece of post and, you know, an envelope with an address on, you write it, everyone has different handwriting. Sometimes it's hard to read people's handwriting, and actually you can start to say, okay, this is a 0, this is a 1, this is 2. Let's find out the postcode, let's find out the street name and the street number and stuff like that. So think of it in that sense. That's where it's kind of applied. So we have 42,000 images, but our data's been broken down. I don't have the image data. What I've put into the studio is actually the broken down version of it. So each image is 28 by 28 pixels, and that has color values from 0 to 255. And what I'm able to do is actually have it in a row of data, so that each pixel is in a row. So you can think in the corners of each like image, it's going to be like a 0. So, but then in the middle, when it starts to see maybe I write a number 7 differently to how you guys write a number 7, then it will start to understand that because it's all in the data. So each row of data is a story, is a handwritten digit. And with that row, we're going to do something called supervised learning, that I mentioned before. So we have that answer, we have that label that actually says, okay, this row of pixels is a number 2, and this row of pixels is a number 4. So, you know, being able to say, this is what happened in the past, this is data from the past, can I then give it new pixels, and it will tell me what number it is. So, let's, if I switch over to my screen and just open up a web browser. Let's go back to... So I don't know if any of you guys have used Microsoft Azure. So Microsoft Azure is Microsoft's cloud computing platform. We have various things from infrastructure as a service, platform, you have virtual machine storage. We also have some really sort of exciting software applications, so applications that you guys can tap into and services such as machine learning that enables you to start building inside the web browser. So machine learning sits as one of the services down the left-hand side. And actually, you can start to create workspaces in there. So I have 4 different ones, including the test one that I really need to delete. But I always think of a workspace as like a folder. So on your file system, I don't know if you're as bad at it as me, but my file system's a nightmare. But actually, you have folders, and you might have a folder for a certain project or a folder for a certain customer. And then that's kind of thing here that's going on. So I have a digit recognition demo workspace, and that's where I keep all of my experiments that relate to this digit recognition app. So if I go to my experiments now, you might have noticed it looks fairly similar, but we've actually moved on to a new tab. So we're actually now in the Azure Machine Learning Studio. So it sits again in that web browser, and you can make stuff from in here. So I've got experiments all down the left, and then web services. It supports R and Python. So for you guys who are data scientists, if you guys code in R and Python maybe, and some SQL transformations that we might be familiar with, you can actually bring your code if you want to and use our compute and storage, which is exciting. But I always quite like to use what some of the modules that they actually give you. So if we just pop into this experiment here, you'll notice now we're kind of sitting in a workspace, and I used to do like product design, and there was something called Pro Desktop, and it reminds me like exactly of that. Some people say Visio, some people say all sorts of different things, but it's kind of this idea of on the left, you have all your different sort of modules, so all these building blocks that allow you to build machine learning algorithms, and then in the center, you have a big space where you can actually start to build it, and you connect all your different pieces. It's quite exciting to see that each sort of arrow is showing the data flow through your experiment. So we start with some digit data at the top, and if I right-click and visualize that data, it'll give me a snapshot of the data that I've got. So I mentioned to you guys we had 42,000 images and 785 columns, so 784 pixels and that label. I also mentioned that the corner of the images is all zeros, so that's why there's all zeros there. But if we actually look at the label column, you'll be able to see that we have a variety, not all the same number of, but a variety of different numbers from 0 to 9 available to us in this data set. And again, this kind of idea of rich data. So if I had a whole load of number ones, it would often predict a number 1 more than it would predict anything else. So being able to have a fairly similar amount of outcomes in your test data, in your training data, allows you to make a better model. So if I just close that very quickly. Okay, so I have how many modules? I have 6 modules on the screen, and this makes a total machine learning algorithm. So at the top, I have my data. I'm actually able to search for data sets over here. So if I go to my data sets, you'll notice that digit data sits there. And actually, if I wanted to data input output, I can actually click and drag a reader onto the screen. And then I can start to read from different sort of cloud storage spaces. It might be from the web, it might be from a database, it might be from table storage or something like that. But actually I can start pulling in my data from all different places. But we just uploaded a static piece of data. So if I delete that. I mentioned in the sort of evaluation part that we don't always trust our algorithms, so we want to test if they're any good or not. So that split data module actually splits it into 2. So you'll notice there's sort of 1 arrow import and 2 coming out of it. If I then click on that, we'll see that there's sort of I've just gone split rows, and I've put about 80% of my training data, 80% of my full data, into the port 1, and then I've put 20% of the rest of my data into port 2. And that's kind of saying, okay, I want the majority of my data to pass to the algorithm and go, okay, go and learn all the different patterns in that data so that you can predict what number's going to come up. And actually, that other 20%, I'm kind of holding back. It's almost like a game of cards. So I'm like holding my cards up, and the machine learning algorithm has learned something, and I kind of go, okay, well, what have you got? So we've split our data, and as I said, we passed that 80% to a trained model. But on the other side, we've actually put in something called a multi-class neural network. Now, this is our algorithm, and this, I haven't coded this or anything. This has literally been provided for you. So if I just go down here to machine learning and initialize model, you'll notice there's lots and lots of different categories in here. So what I can do is, if I go into classification, this problem is multi-class classification. So what is that? That is where I have numbers 0 to 9. So that means I have 10 different buckets kind of to put these numbers in. So I look at some pixels and I go, okay, that's number 2, so I put it in number 2 bucket. And I look at some more pixels and it's number 8, so I put that in number 8 bucket. And actually, multi-class classification means exactly that. The machine learning algorithm looks at something and it goes, what is the probability this is a number 8? And if it's quite probable, it'll go, okay, I'm going to put it in that. I'm going to say this is number 8. And the neural network part, I don't know, actually, one of my colleagues gave me a really funny quote. He was like, I think neural networks are like unicorns. And I was like, sorry, what? And he says, everyone's heard of them, but no one's ever seen one. Like, no one knows how they work, sort of thing. And I was like, actually, that's a really, really good analogy, because a neural network kind of comes up a lot. A neural network has been designed around how our brain works, so how our neurons connect. And when they do connect, they kind of remember a pattern and they light up. So, really, really exciting algorithm, very, very powerful, can find really deep patterns in data. But actually, it takes quite a long time to train. So if you have a lot of data, it takes a lot longer to sort of process this model. So you might want to choose other algorithms. Now, I'll show you something that help you do that, but just bear with me that this one's a good one for this problem at the moment. So, and you might also notice on the right there, I've got loads of different numbers and fully connected cases in my hidden layers and what? So basically what these are the parameters. So you know how I said unsupervised learning, the machine learning algorithm starts to move its own parameters? Well, that's kind of what those parameters are. They have nodes and learning rates, and in other algorithms they have trees, and number of trees and numbers of leaves and stuff like that. And most people come and they go, oh my God, someone told me this was going to be easy, what's happening here? And actually, what's been really nice is actually Microsoft Research do a lot of research around these kind of machine learning models. So what they've been able to do is actually package these models up, pass them to Azure Machine Learning so you guys can use them, and actually put in some sort of default parameters that are going to mean that you can just run it. Now, it's not necessarily going to optimize for your data, but this is kind of a generic set of parameters that are going to work, and then you can start to tweak them. And there's various modules as well in the Azure Machine Learning Studio that can do that for you automatically based on your data, which is exciting. So now we've got an algorithm, and we've got a whole load of sort of data that's all these different images. And basically, I'm going to say in that train model, I'm just saying, okay, go and learn what that label is. Look at every pixel row and tell me what the label is, and go and learn all those different patterns. Next, we want to score the model. So we want to just score the model. It has no properties, the score model one, which is good. And basically, all it does is sort of this simple arithmetic. So you'll have that deck of cards kind of thing. So I have my test data, and I go, okay, for these pixels, what do you get? And the machine learning goes, okay, I get number 4. And then I go, you were right, because I have that label. I have that right answer in my test data. So it's really simple to just go, you got that one right. Okay, you got that one misclassified. That wasn't quite right. You said number 2. It's actually number 8 or something like that. And then finally, we provide a nice little evaluate model module that if I right-click, and visualize that, it gives us some statistics on how well we're doing. You guys are going to look at it and go, whoa, 97% accurate. She's like a machine learning god. No, not quite. This is a test data set, so I wanted it to look really good. But no, it actually did a fairly, really good job with this test data set. But if we just have a quick look at what's going on down here, this is a confusion matrix. And basically, what it's telling us here is down the diagonal, we have all the right answers. So where the machine learning algorithm put the number 1 in the number 1 bucket, and where it put the number 8 in the number 8 bucket. And actually down that middle bit, that's where we want it to sit. And actually it's got some some decent numbers in there, 90 odds percent, and you're like, oh, okay, not too bad. So the predicted class, so the one that the algorithm said is at the top, and the actual class, so the one that I've got in my test data, is down the side. But it's quite interesting to see, for example, this one here, a 1.8%, which is one of the largest errors there, is actually where the machine learning classifier has said it's a number 6, and actually it's a number 5, and actually it's a number 3. So you can kind of see why that might happen. A 3 and an 8 do the same thing, because when you write a 3, if you write it like really, really curly, it might look like an 8 because you're just missing bits on the side. Or maybe if you write a number 9, but you write a really, really tiny little like head on it and just a stick, maybe it'll misclassify it as a number 1. So you can see why it might do those different patterns. But this is quite good to just sort of sense check how good your algorithm is. Okay, so So we've got a model there. We've got a model in 6 different modules connected together. So that's quite good. But I mentioned that we want to kind of deploy this. We want this to be usable. We want a web service. I want to be able to call this with a whole load of pixels, and it passes me back what number it is. So all I need to do now is actually click on this train model box and say set up as a web service and a predictive web service. So if I click that, I'm going to do a here's one I prepared earlier kind of thing. So if I go to this one here, what it actually creates is another tab. So you notice at the top now we have a training experiment, but we also have a predictive experiment. So training is where we're kind of building the model, we're experimenting, we keep going around and checking it's going to get better. And in the predictive experiment, we actually starting to say, okay, I want this now to go into production. I want this to start to predict for me. So how are we going to do that? Well, you might notice it's actually changed it slightly. We've lost some modules and we've gained some. So some of the... Thanks, whoever tweeted that. So we've got a web service input and a web service output. And basically we're saying, okay, our user of our application is going to come in at this point, and actually we want them to leave at this point. So what do they pass us as the data, and what do we get back as the user at the end? So we have our digit data still up there, we recognize that, but our split module's gone. Well, that's because they're going to pass us the data, so we no longer need that bit. You might also notice the train model and the classifier is gone. And that's actually all now been packaged up into this digit recognition demo module. So it kind of like merges it all together for you automatically and says, okay, you've now got a model that I've built into a module for you that is a multi-class neural network, and it's got your data in it. So that's what's so specific about it. This is actually your model. It's not generic. It's not got a generic set of data in it. This is exactly what you passed it. And actually, they sit now in this trained model boxes. So if you wanted to, say, use this in another experiment, you can simply click and drag it on instead of building it all out again. So it's kind of reusable, which is nice. We're still going to keep our score model module, because what we want to do here is actually when that user passes in the data, we actually want it to go, okay, here's the data, here's our algorithm, put them together and give me an answer. And actually out of the score model, we get some scored labels. So that's my algorithm saying, okay, this is a number 4. But we'll also get a scored probability. And the probability is saying how confident it is that it's a number 4. Now, it could be really, really confident. It's like 90%. It's like, this is definitely a number 4. I'm absolutely certain. But when you start to err around sort of like And in a binary classification, so sort of 40 to 60%, you might want to go, oh, okay, it's not too sure. It's given me a prediction, but actually I might want to intervene here. So think about scenarios where the answer really matters. Healthcare. Healthcare, the answer is absolutely paramount. You're dealing with people and in people's lives. So actually when you say, from all your symptoms, we could maybe predict what treatment you need or what might be wrong with you, and actually that is really paramount. Like, you can't tell someone that they're ill if they're not, or you can't tell them they have one thing if they haven't, because they'll get treatment for it. So that's where we need to intervene. That's where the human sense and we make decisions. This kind of machine learning is making decisions just on data. It's just making decisions on patterns. It has kind of almost no semantic understanding of what it's doing. Now, there are machine learning things out there that are potentially going to have semantic understanding, and I'll show you an API that might do that. So very, very quickly, we've got a project column module here, and all we're saying is I want to pass back to the user what that number is. So if it's predicted it's number 8, I want to say, okay, pass that back to the web service. I pass you a load of pixels, I get the number back, and then you have a web service output. Now, that is now built, it's ready to deploy. So what I was able to do is just say deploy as a web service, and it actually creates me a web service page that sits in Azure Machine Learning Studio. It gives you your key, and actually it also builds you some documentation pages, which everyone can go, yeah, we don't have to write documentation. So that's always really good. It gives you sort of sample requests. It gives you data endpoints where you post this kind of stuff. This is actually quite a bad example because it has a million different pixels. So you would pass this from an image. But actually, if I scroll all the way down to the bottom, sorry, my mouse is being a bit funky. Oh, this is not going well. So if we scroll all the way down to the bottom, we basically have sample code there. So some of the sample code we provide is in C#, R, and Python. So in case your data scientists want to kind of have a look at it and check that they can use the language that they understand. And all you can literally do is click select sample code, Control copy, pop it into your project that you already have, an application that you've already built, and all it does basically is give you a whole web service output. You'll notice here, this is completely personalized for my experiment here. So it's saying, okay, you have 0 to 784 pixels, and you have a label. And also, it's got scored label and scored probability. The only thing you have to remember is basically the key. We put ABC123. This is on the web, so studio.azureml.net, and then a whole load of sort of long numbers. But if someone was to crack that, they could take it if the key was in here. So we don't do that. The key is in the place where you have to sign in, so you can use sort of directory and security services sort of around this stuff. There's lots of options to say, okay, do I want it request response? So do I want to pass one piece of data and get one prediction back? But actually, if it's sort of a lower cost scenario, so you can run a whole load of data in batch, maybe overnight, you might want to do that, and you send a whole load of data, and it gives you a whole load of predictions back. So that is an end-to-end machine learning model. And actually, I was able to build it into an application. Now, again, this could be, if you think about it, kind of anything. Let me cancel that. And so this is my phone. And someone from Microsoft just emailed me. So basically, what we have is lots and lots of different apps pinned, but there's this guy with kind of like a white beard down here, which has Azure ML digit recognition. So if I open this app, it's built using that example, using that experiment. And what I'm able to do now is write number 2, waiting for results. It's calling off to my API, and it's pulling me back a piece of data, and it's just said, okay, it's number 2. So this is where it gets risky. When I'm in public, I shake a little bit. But so we're sending it off again. It's pulling us back a result, and it says number 3. So, I mean, this is kind of trivial, and everyone's going, what is the point of this? But actually, you can see how this kind of thing could be really useful. If you have a website out there, Maybe it's an e-commerce website and you want to give a user some recommendations. You can build a model, you can deploy it, and you can simply put it into the application that you already have. And we've built an application around this to sort of highlight its features, but this could have been put anywhere. There's no reason for this to have to sort of build a whole new thing. So if I just cancel that. So that was us sort of building our own classifier. And so that was us building our own classifier. And we want to, I don't know, we've done a fairly good job there. We were learning lots of different things, but there was this kind of issue around, God, what is a neural network? Which one do I choose? There was a whole list of algorithms there. Well, actually, luckily, we provided a little algorithm cheat sheet. So it's, you can see it okay, that's not too bad. But it's actually at aka.ms/ml cheat sheet. And you can go to this, and basically it just kind of points you in the right direction for maybe the problem you've got. So say you wanted to do, well, what we've just done. We had predicting 3 or more categories. We had 10 categories to predict. So we go into that little blue box at the top. We used a, multicast neural network. So it says, yeah, it's super accurate, but actually it has really long training time. So maybe that was kind of why I did so here's what happened earlier kind of scenario. But actually, if I'd maybe used a multicast decision jungle, it would have been super accurate. It would have a small memory footprint, and it would have trained faster. So there's all these different things. And again, if you have this kind of curiosity around machine learning and you go and look these things up, it's really exciting to see actually which one is useful for which. So do check that out. Do have an explore around it if you start to use the studio. So that was us building them. We built a digit recognition app. We built an algorithm. We used a neural network. But actually, this stuff's kind of been done before. Well, the Postal Service has done that. The Postal Service has obviously got every letter, and it's able to interpret words, and it's able to then sort of send letters to the right places automatically. And that's really good because it's efficient. So if it's already been done before, maybe there's something out there that we can call. And actually, Microsoft have built some machine learning APIs, a suite of them, and we've called them Project Oxford. So yeah, it's www.projectoxford.ai. And I wanted to talk to you a little bit about some of these. So did anyone see this website? It was called howold.net. Yeah, brilliant. Did you put your face into it? Did you take a selfie? Good stuff. And basically, howold.net is, we built it as an example when Project Oxford was launched at Build, which is Microsoft's developer conference. And they kind of didn't expect it to kind of go anywhere. It was like, oh, we'll use it for, an hour, and then our employees can use it afterwards to show people and stuff like that. And actually, as it does with social media, the minute it goes on social media and someone can get involved, it starts to go out of control. And we end up having like millions and millions of images being put into it, and people trying to rate what their age and gender is. So that's what it does. It gives you your gender and your age. There was some exciting anomalies. Someone put like a leek, like a vegetable, in front of it and said, can you predict my age and gender? So that's always good fun. Someone put the Mona Lisa in front of it. Someone put a picture of Jesus in front of it. There was all sorts of really, really good fun stuff. And it was like, okay, can it predict your age? So I put my face into it. And it got me pretty spot on, actually. I was very, very happy. So it said I was a female. If it had said I was a male, I would have automatically closed it, and I wouldn't be here today. And then, and it said I was 24. Well, I'm actually 23, so that's not too bad. I do think I look quite young, though, so I was quite surprised. But it was good fun. My boyfriend got heavily insulted and was like, no, I don't want to see that again. But this is a success, and then we wanted to show people that actually it was really good fun to build this kind of stuff. So we had 2 developers in one of the machine learning teams built this in 2 days, including all the back end, including lots of dashboards of different devices that these things had come from, whether they'd accessed via the web or the app and stuff like that. So lots and lots of different data, which was fun. So we made many. So we made twins or not, so you were able to compare yourself to a celebrity. I don't know if you guys watch it, so I didn't put it in, but there's something called the IT crowd. Have you guys watched that? Yeah, yeah. So the girl in it. Yeah. So me and my friends at uni used to get called the IT crowd because there was me and 3 lads, and you can imagine which one they thought I was. So I put it in, and actually it was like 40%. So 46% similarity between me and her. So that's cool. So actually, more recently, we announced mymustache.net. Please do go there now and pop yourself in. If you have a moustache, it will rate how good your moustache is. If you don't have a moustache, it will. You can actually get it to put a moustache on you. So it says, "I don't have a moustache." Luckily, again, if it had said I did have a moustache, I would have closed it. And actually, I can just go, "Okay, put a moustache on me." So it's all good fun. And actually, it was built around sort of Movember, so for male health awareness. And again, good fun technology for good causes is always fabulous. So I thought I would show you that, and please do go and use mymustache.net. But the key point of this is basically, what is Project Oxford? So Project Oxford is a set of SDKs and APIs that you guys can tap into to put intelligence into your app. And these things are kind of fairly regular scenarios that we might be seeing now, and you guys don't have to go away and build your own version of it. You might be able to tap into some of our versions. So we have a whole load of different ones. We have vision APIs, and they have different options in there. We have face APIs, so they're the ones that were used on howold.net and mymustache.net. Still can't go over that. We have speech APIs, so being able to do speech to text, being able to get intent in speech, which is exciting. And again, on the side of intent, I mentioned that our algorithms found patterns. Well, Lewis is a language understanding service, and he's able to sort of understand intent and entities when you maybe pass some sort of relevant domain data that you might have to it. So do go and have a look at these ones. Actually, I was at a conference called Future Decoded in the UK on the 10th and 11th, and what we were able to announce, we had our CEO Satya there, and he was able to announce with Chris Bishop from MSR that we've got some new APIs coming, so I was really excited about this. So I popped them into the slides, so it was totally up to date. We have an emotion API coming, so you can pop a picture in there and it can say what kind of emotion it thinks you've got on your face, so you might be smiling. If someone had taken a picture of me earlier when I was prepping my slides, I might have looked worried. And also we have a spell checking one. Some really exciting stuff I found out that's totally relevant, hopefully, to you guys, is actually on GitHub. If you go to that Project Oxford link there, we have lots of all the GitHub examples and stuff, so you can start building really quickly with these. We have Windows Phone, and we also have Android. So if you guys are Android developers, please do go and have a look at those. So I've got time. I've got 8 minutes. So what I'm going to do is I wanted to show you very, very quickly an example of using some of these APIs, how I've built them into something. So I have this website. You know how I said before, I always think of a machine learning, like a glowing orb? Well, I asked one of the guys who's on the web dev team to make me a glowing orb. So he did this for me, which is really cool. And basically what I can do here is if I open some of this code and just get these running, I've actually started to do this for the Devoxx hashtag. So as you guys have been tweeting, hopefully if you tweet now as well, it'll be really useful. So that's just running through some of my old ones. There we go. So someone has just tweeted now. It comes up in the top one. Oh, you can't see it very well, but there's a tweet in the top one there. We have a funky... Sorry, I seem to be having some kind of lag on my mouse. So at the moment, the Devoxx hashtag has a sentiment value of 81. So this actually uses the text analytics APIs that Project Oxford provides. And what it can do is I send off a tweet. So each one of your tweets gets sent off, and when I get it back, I get a sentiment score and some keywords. So this is always good fun. So basically, what I'm able to do is send that data into the cloud. I do some processing over it in real time, and I push it back down to a website in another API, and actually am then able to display it. So every 10 seconds, this is refreshing with an average sentiment. When I've been testing it, where are the dinosaurs? Exactly. That's actually a really good idea. I'm going to now put a dinosaur picture on this because I tend to do these two things together. So, but yeah, so basically on the bottom one, we've got that every 10 seconds, it's coming back with my average sentiment. So that's all coming from the cloud. So it's going device to cloud and back to the device again. And what's really nice is just kind of seeing sentiment analysis is an interesting one. Very, very popular. Don't build your own. There's so many out there, including Microsoft's offering. So please do go and try out these things and just go, actually, if I have a load of event feedback or if I have a load of verbatim reviews on an e-commerce site, maybe I could start to sort of go through these a bit quicker and do something interesting with them. So just a little bit of fun. Thank you for participating. It always makes it much better when people tweet in real time. So if I just close them very quickly. So this is very, very quick, but I just wanted to kind of say that you might notice that the machine learning part was actually just one part of a much bigger problem. So in the sentiment analysis one, we had a website front end, we had some web jobs running, we had the machine learning part, we had some storage, we had some, there's all these different parts of the jigsaw, and we actually have something called Cortana Analytics Suite, it was announced quite recently as well, and all these different services sit in the cloud, and I just wanted to highlight the fact that you can build a model, but please do consider the end-to-end solution, because that's the exciting part of it, when you can give someone sort of an end-to-end that does things automatically. So for the one I just showed you, I used Azure Machine Learning, but I also used Azure Stream Analytics and Azure Event Hubs. So event hubs are just like mass ingestion of data. So it's just tweets. So it doesn't matter if they're out of order or anything like that. So that's it from me. Thank you for listening. Some of the next steps I'd like you to take, basically, build something innovative. Let me know when you do, because I'd be really interested to see what you build with it. So do go to projectoxford.ai and check out those APIs. Investigate those other services that I've flicked up real quick on the data platform, because actually pulling these things together is exciting. And as I said, if you build something, please tweet me, let me know, because it's just nice to see technology companies create technology. And actually, it's what you guys do with it that makes it far more exciting, because we always see that people use it in completely unusual and unexpected ways, and we really like to see that. So thanks a lot for your time. And I think if there's any questions, feel free to ask them. Thank you. Hey, yeah, here's a... Yeah. So the question was, I sent off some pixels and it brought me back a 3. Can it do anything but numbers? Absolutely. So with the Twitter sentiment one, I called an API, but actually I've also built a model around Twitter sentiment analysis. So it can pull me back values, it can pull me back booleans, text, anything really. So yeah, it's very, very good at handling lots of different data types. Yeah, so you can you add logic to what it returns? Absolutely. So I just sent back the scored label, but if you wanted to say, okay, I want the scored label, then you can start to add, underneath that score model, you can start to add all different stuff before you put it out the web service. So if you wanted to do some data transformation on it afterwards, or like you said, a logic transformation or something like that, you can absolutely do that and then send different data back to the user. Yeah, no problem. Oh, one more. So that was the question around cost. So as it's a service, it sits on the cloud. When you're designing there's actually a free version of it. So you can go and get a free workspace right now, and it costs you nothing. It's not limited, but you can't deploy web servers and stuff like that. So when you want to put it into production, you sign up. you pay like a seat per month, so it's like £5 a month for like a seat. And then basically when you start to process data in the studio, you're paying like pence basically per hour of processing. And so if I give you a sort of idea of how quick it processes, so in another example, I have like 2.5 million rows of data, and I'm able to do it in a demo situation. So it takes like 30 seconds tops to maximum, to actually evaluate that. So really, over an hour for only a few pence, it's very, very, very good at that. So, thank you. Yeah, just over here.
Any other languages going to be supported, like Java, for example?
Yes, yeah, no. So I wouldn't know that at the moment. I'd like to think so. At the start, there wasn't really much support for languages, but over time we've been adding to them. So R, Python, C#, SQL. I'd like to think it would. One thing that I would ask you guys to do actually is in the studio there's a little smiley face at the top, and that allows you to give feedback. Microsoft work very much in that sense now. With Windows 10 we've done exactly the same thing. We want you to give us feedback on when you're using it. We put technology out early so that you guys can tell us what you want to use it for. So if you guys all go and say, we want Java in this, because Java is actually used for machine learning. So it'd be nice. Please do give feedback. It actually means more from you guys than it does from me. So please give feedback, and it'd be nice to see lots of languages in the future. Any more questions? Yeah. Based on real user input, yes. So we have a retraining part. So sorry, the question was, can we sort of relearn given real user input? So basically, the Howell.net site was a good example of that. We actually never gave the opportunity to give feedback. So when my boyfriend got heavily insulted, it was quite interesting because he was like, I'm not 40 years old, he's like 25. So he basically said it would have been nice to say, oh, actually, no, I'm 25. Please use my little tick box or something. Please use my picture to relearn. And actually, what you can do is set up something called retraining, where you can then feed that data back into the model. Maybe with an answer that the user has provided, so like crowdsourcing the problem in some senses. So yeah, that's absolutely available, and there's some blog posts online if you type in Azure Machine Learning Retraining. Yeah. So recommendation on in production. No, sorry. Yes. So we chose a multi-class neural network. Why did we do that? Is there a way that it can recommend which model to use, right? Okay, so interesting part of it is, how we had that evaluate model at the bottom? And because we were kind of clicking and dragging and it was really agile, what we can do is we can have, we had one side of the classifier. We could literally copy and paste that, attach it to the other side and just replace that module. So you can literally just take that out and put another one in. And you can directly, in that evaluate model box, you can directly see the comparison between the two. So if you use that machine learning cheat sheet and you go, okay, I have a choice of 4 different algorithms, you can test them against each other while sort of looking into what they do and stuff like that. Another interesting source, so it doesn't do it automatically for you, but it has options where you can compare very quickly the accuracy of 2 classifiers, which is great. So it is absolutely possible. A little bit of work from you guys, but if you can read into each algorithm also has a little help page button at the bottom, and when you open that, if you scroll down a bit, it's a bit like a wiki page. At the bottom it says, how have people used this algorithm before? What kind of problems has it been used for? So there's little examples in sort of plain English, not in machine learning talk, around how this algorithm has been used before. So has it been used in recommendations? Has it been used when the data is linear or the data is numeric or something like that? And it will give you those examples. Okay, I think I have to go because otherwise I'll hold up the other people. I'm around. I've got another talk on as well, so please come and see that. But yeah, thank you very much.